In 1982, there was one SAT question that every single student got wrong. Here it is. In the figure above, the radius of circle A is 1/3 the radius of circle B. Starting from the position shown in the figure, circle A rolls around circle B. At the end of how many revolutions of circle A will the center of the circle first reach its starting point? Is it A, 3/2, B, 3, C, 6, D, 9/2, or E, 9? SAT questions are designed to be quick. This exam gave students 30 minutes to solve 25 problems, so about a minute each. So feel free to pause the video here and try to solve it. What is your answer? I'll tell you right now that option B, or 3, is not correct. When I first saw this problem, my intuitive answer was B, because the circumference of a circle is just 2 pi r, and since the radius of circle B is 3 times the radius of circle A, the circumference of circle B must also be 3 times the circumference of circle A. So logically, it should take 3 full rotations of circle A to roll around circle B. So my answer was 3. This is wrong. But so are answers A, C, D, and E. The reason no one got question 17 correct is that the test writers themselves got it wrong. They also thought the answer was 3. So the actual correct answer was not listed as an option on the test. Mistakes like this aren't supposed to happen on the SAT. For decades, it was the one exam every student had to take to go to college in the US. It had a reputation for determining people's entire futures. As a newspaper from the time stated, if you mess up on your SAT tests, you can forget it. Your life as a productive citizen is over. Hang it up, son. Of 300,000 test takers, just 3 students wrote about the error to the College Board, the company that administers the SAT. Shivan Kartha, Bruce Taub, and Doug Youngrice.
I did a lot of math problems when I was young. For the competitions, I probably did thousands of math problems. I read it, and I was amazed how badly it's worded. I just put 3 down. I figured that's what they wanted.
The 3 students were confident none of the listed answers were correct, and their letters showed it. As a director at the testing service recalled, they didn't say they had come up with possible alternative answers or that maybe we were wrong. They said flat out, "You're wrong," and they proved it.
I discussed it with some other people and said, I think there was a mistake, and they mostly said, no one cares. I wrote a letter to the Educational Testing Service. It was a little while later. They called us and said, I was correct.
Here is their argument. The simplest version of this problem is with 2 identical coins. These have the exact same circumference, so by our initial logic, this coin should rotate exactly once as it rolls around the other. So let's try it. Okay. But wait, we can see it's already right side up at the halfway point. So if we finish rolling it around the other coin, it'll have rotated not once, but twice. Even though the coins are the exact same size. There are no tricks here. You can try it for yourself, and I'll do it again slowly. It's 1, 2. This is known as the coin rotation paradox. This paradox also applies to question 17. I've made a 2-scale model of the problem. One useful tip for standardized tests, even though they say their images are not to scale, they almost always are. So when we roll circle A around circle B, we can see that it rotates once, twice, 3 times, and 4 times in total. So the correct answer to this question is actually 4. Once again, the circle rotates 1 more time than we expected. To understand this, let's wrap this larger circle in some ribbon. And I'll make it the same length as the circumference. And then I will stick it down to the table as a straight line. I'm adding some paper here, so there's something for this to roll on. And now it rolls 1, 2, 3 times. What's happening when we turn this straight path into a circular one is that circle A is now rolling the length of the circumference and it's going around a circle. The shape of the circular path itself makes circle A do an additional rotation to return to its starting point. So this is the general solution to the problem. Find the ratio between the circumferences of circle B and circle A, and then add 1 rotation to account for the circular path traveled. But there is a way to correctly get 3. Let's count the rotations of circle A from the perspective of circle B looking out at A. We can see circle A rotates 1, 2, 3 times. And it doesn't matter which circle you are looking from. To circle A, it also rotates 3 times to come back to its starting position around circle B. Similarly, from the perspective of the coins, we can see that the outer coin only rotates once as it rolls around the inner coin. Using the perspective of a circle is just like turning the circle's circumference into a straight line. It's only as external observers that we actually see the outer circle travel a circular path back to its starting point, giving us the 1 extra rotation. But there's even another answer. If you look closely at question 17, it asks how many revolutions circle A makes as it rolls around circle B back to its starting point. Now, in astronomy, the definition of a revolution is precise. It's a complete orbit around another body. The Earth revolves around the Sun, which is different from it rotating about its axis. So, by the astronomical definition of a revolution, circle A only revolves around circle B once. It goes around 1 time. Now, other definitions of a revolution do include the motion of an object rotating about its own axis. So 1 isn't a definitive answer, but the wording of this question is extremely ambiguous if you can justify at least 3 different solutions.